Pakistani fishermen recently returned to port with surprising news. Hey, we found a new island! This mud volcano is a temporary feature and is already eroding thanks to wave motion. These appear at irregular intervals and are due to plate tectonic activity. The two large crustal plates in this part of the world are moving against each other at a sedate speed of 1.5 inches per year. The volcanoes form from mud sloughed off as the plates scrape against each other. The process begins when heat from the crustal motion turns seawater to acid, which melts rocks, turning them to slurry, which then erupts to the surface through fault lines. Here's a region of Antarctica pictured in December during the height of its summer season, when the sun's in the sky 24 hours a day for 6 months. During this time, it makes a complete circuit of the sky, hugging the horizon. The sunlight's low angle in this image highlights the differences between the icebergs and also produces eerie, long shadows. The icebergs with rough surfaces probably broke away from the coast. As they bobbed over the ocean, wave action applied pressure, which moved up through the ice to the surface. Fractures then appeared, into which fell more ice and snow, which widened them further. By contrast, the smooth-surfaced icebergs probably originated in this region and haven't moved far yet. The image's left side shows sea ice, beneath which can be seen the ocean. But clinging to the shore, we see what's called fast ice, which is thicker. The Anyuski volcano rears up from the barren plains of northeastern Russia like an angry boil. Crustal plate movements mean this beast is now dormant, but we are seeing evidence here of what it did in its prime, namely producing an avalanche of rock and ash known as lahar mixed with water. This molten river flowed for 30 miles down the west side of the volcano's summit. Today, it's dried and hardened, pictured in red, nestled between areas of rich vegetation that feed off the minerals released during eruptions. Depending on how they're created, lahars can be cold or scalding hot, and they have the texture of wet cement. The far reaches of northern China are well known for suffering from dense smog, produced by man-made pollution. Here, we see a particularly severe recent example that was so dense the ground isn't visible in some areas. Smog occurs more often in the winter, when the atmosphere's higher water vapor content traps more pollutant particles. The smog here contains mostly soot and ground-level ozone. The soot originates from the burning of diesel and coal. A side effect is the creation of ozone when these elements are exposed to sunlight. Many Chinese people use coal to heat their homes and for cooking. China is one of the highest consumers of coal and would therefore benefit the most from a reduction of emissions that cause severe respiratory problems. Images of towns flattened, as though the 4 horsemen of the apocalypse just rode through. Tens of thousands of lives lost, shattered communities and devastated economies. These are the consequences visited upon the good people of northeastern Japan in the wake of the terrible tsunami and earthquake that struck the region. The lower image shows the region as it used to be, the upper picture as it became. Post-tsunami, it's difficult to see the coastline. The flood indicator shows how far inland the waters spread their devastation. A red box highlights local fires, and we can see plumes of sediment washed into the sea from farmlands. Meanwhile, halfway around the world, mudslides have wreaked havoc in the Brazilian cities of Rio de Janeiro, Santa Catarina, and Sao Paulo. Again, the top image is post-disaster, showing dozens of tan-colored strips of land where the hillsides have been smothered by mudslides brought on by heavy rains. On one day alone, 10 inches of rain, 1 month's worth, fell in the mountainous region. This produced terrifying flash floods and rivers of fast-flowing mud that killed over 1,000 people. 9,000 more were left homeless. Geologists say the weather was caused by a well-known phenomena called La Niña. But the damage was made worse by the long-term building of communities on hillsides that used to be tree-covered. Now, however, the soil cannot hold on to as much water. The Brazilian government have announced that they will spend the equivalent of $4 billion over 3 years on a series of nationwide water drainage and hillside recovery projects. Join us next time for more insights into current happenings in our natural world, brought to you by Starlight Express.